have got some queries from the organizers as well that there must be some sort of alignment with respect to the content of this thematic area of this particular workshop or FDP program, that is of network science. So I would like to clarify that you see nowadays we are working in broad sense, like for example, if the thematic area is network science, so it consists of various aspects. So I mean to say it may consisting of computing, it may consisting of security, it may consisting of network management, resource management, and various other things. So keeping in view of the interest of the emerging trends nowadays we have, I kept that particular part in this context in the sense that it should cover various aspects and it will give the glimpses to the audience that the various technological trend as well as research trends as far as this network science concept is concerned. So in broad sense, you can see the network science is a broad concept which consisting of that association of various types of devices, and these devices, how these devices are able to communicate with each other using various types of communication standards. We need to take care of various types of communication standards, and then apart from this, we also have various types of devices which are used for communication purposes also. So that for those communication purposes also you need to take care of various aspects. Like for example, this should also consisting of concept like machine learning, like network management, and other concepts. So those are just an indicative topics on which this whole thematic area of today's workshop is concerned. So today's talk is more about the network management part, and also how these devices which are part of various network models communicate with each others, and they are about to share their data using in a collaborative manner, and that collaborative manner will be taken care by most important concept nowadays, which is about the federated learning in network science, right? So we will start first of all the underlying network infrastructure which is used to keep track of data analytics part in this network science paradigm. So we will start with that particular part first of all, because you see there may be some sort of networks in which various types of devices are interconnected with each other, and these devices are able to transmit the information or sharing the information with each other using various communication standards. So these communication standards are based upon most of the times these protocols, that is most important protocol that is being used for taking care of routing and other parts is TCP/IP protocol that is being widely used for communication between different devices. As far as the range and as far as the transmission is concerned, so there may be some other technologies or other protocols that may be also used for short range communication or medium range communications or long range communications. So the nowadays the technological trends has been there that we should be having a communication beyond thinking, that specifies that we should be taken care of the communications of various devices that may be located across the terrestrial part, that may be consisting of UAVs, that may be consisting of space communication, that may be consisting of aerial communications. So I mean to say here that we should take care of communication with respect to space, air, or underwater communication. So all those types of communication would be consisting of the transmission between different devices, and these devices which may be located across different geographical locations, and they may be at any point of time either in the space, air, or underwater, or maybe or on they may be on terrestrial on communication also. That will also be integral part of these type of communication. So these types of communications having a technological trends, or we can say a trend, right, starting back in 1980s to let's say in 2050, 2025, or 2030. You see there has been a technological trends when in 1980s we are talking about voice calling, and it consisting of 2.4 kilobits per second. So nowadays we are talking about let's say 10 gbps speed with bandwidth spectrum from traditional change from 1G to 5G or to the 6G itself. So how this revolution has been taken care of with respect to the application standards, like for example back in 1980s, we were talking about voice calling. Then we in 1990s we are talking about SMS. Then the revolution of internet was taken place in 2000. Then internet of things application comes in 2010, and then massive broadband communications and internet of things with respect to audio, AR, VR, and other applications that comes in 2020 and beyond that particular part itself. So all of these you can see there had been a technological revolutions. This technological revolution which has taken care of from the different generation. The prime aim of this technological revolution is to get high speed and efficient bandwidth spectrum utilizations with respect to the network management policies, design, and other parts are also. So I mean to say here, the upcoming 5G or 6G technology will contribute to fill the gap between various types of applications and demand that had been raised from the last few years to support like these types of applications, where we have audio video applications, where we have smart controllers, where we have autonomous vehicles, smart healthcare applications, surveillance systems. So these are some sort of application in which these types of high speed communication would be required. And for this much high speed communication, obviously you need to take care of various aspects. So you see that nowadays the task of any controller is to design is to transfer the data from between different devices at a high speed. So let's say we have one devices at this location, we have another devices at this location, and these devices may be located across different geographical locations. So these devices want to share the information with each other so that they can make an efficient decision with respect to data transmission between these devices. So that will take care of that the underlying network infrastructure through which this communication will happen should be highly sensitive, in the sense that it should be able to transfer this much amount of data in per unit interval of time, that is 1 second. So you can see that this industry revolution has been there nowadays, and earlier we are talking about industry 4.0, and now this industry 5.0, and we are talking about industry next industrial revolution that is going to be taken place. That is next technological revolution is expected to be revolutionized with respect to these types of applications that we people are talking about. So for realistic of all those applications, whether we are talking about e-healthcare application or autonomous vehicle or smart controllers or robotic systems or audio AR VR applications, or we can say UAVs for smart surveillance system, we need to have a new bandwidth spectrum. We should have cell-less technologies. We should have this disaggregation and virtualization should take care of this particular part. And also we should be having an energy efficiency part. We should have artificial intelligence and data analytics part. So all in all, you can see that these applications which we will see in the future have their own stand in terms of benefit of the end users, but for smooth executions or smooth we can say handling of all those application, the underlying network infrastructure which will provide the seamless connectivity among different we can say entities or different applications. We should have the high bandwidth spectrum, that is, or high bandwidth or high speed that is required among all these devices which are part of these technologies or these applications itself. So that's why you can see the vision of 2050 beyond 2025 or 2030 is to get this much amount of bandwidth so that these types of applications can be fully utilized with respect to their operational efficiency in this upcoming environment, with respect to defining out new protocols with high data transfer and the efficient communication between different devices. So why there is a requirement of 5G or 6G technology which is going to be taken care of for communication among all these devices. So you see today 5G is a strong technology that is consisting of development with respect to various horizons. So it has a certain limitation with respect to future needs. So the vision of 6G vision for 2030, the society will be data driven, and there may be served by near instance unlimited wireless connectivity that would be required. So ultimate goal is to meet the novel network demands. These novel network demands will be consisting of ultra high reliability applications, high capacity and efficient and low latency in a holistic manner that will answer the new needs of technological revolution of 2030. For example, let's say we have this type of applications like for example in this scenario we have autonomous vehicles or autonomous robots, or we may have let's say this e-healthcare applications, telemedicine applications. So you can see these autonomous robots are also involved in performing these robotic surgeries in the near years to come, maybe in 2030. So for those applications where we require uh, a time delay of very minimum we can say duration, so for those types of application where these autonomous robots are performing e-healthcare applications, or they are performing operations, or autonomous vehicles are carrying surveillance applications. So for all those types of applications, there is a requirement of integration of space, aerial, terrestrial, and maritime communication in a robust network. So I mean to say here, these devices may be located at any place in the world. They may be in the space, they may be in the aerial communication, they may be on terrestrial, they may be on underwater communication. So there will be a seamless connectivity among all these devices which may be located around the globe across different geographical regions. And to connect all those devices in a seamless manner and to take care of the data transmission between these devices across different geographical location, we needs to have a strong backbone network infrastructure which should be taken care of with high speed requirement, with robust connectivity, and that will can provide fast communication among all these devices. So that's why you can see the future is the testing or installation of 6G communication in network scenario, and that is about to happen in with the revolution of this with the revolution of this 6G communications in the upcoming applications. Like for example, I have given you some sort of application like audio, AR, VR applications, telepresence, teletransportations, e-healthcare, connectivity, Industry 4.0, and robotics part, unmanned aerial vehicles that are used for surveillance systems or smartphones uses. So all of those will require mobile robots and drones, and they will consisting of massive, ultra reliable, low latency applications that may be used for human centric devices, bio internet of things, nano internet of things, mobile broadband, and reliable low latency communications. So there may be a number of research issues which can be taken care of with respect to the evolutions of this upcoming 5G and 6G technologies in the years to come, because there may be some sort of lower layer encoding decoding mechanism may be required, or there may be some other part is also associated, like how to design the issues associated with upper higher layer. So those are some sort of applications which needs to be taken care of for the revolution of this part, right? So the ultimate roadmap that had been started with the release of various types of we can say uh, communication standard is with respect to this slide, which take care of that how this space, air, ground, and terrestrial communication will take care of with the revolution of 5G back in from 2017 to 2030. So you can see uh, uh, in this bandwidth spectrum, we are talking about more than 500 gigahertz with less than 1 terahertz bandwidth frequency, and it has consisting of battery-less devices, and network provides support for energy harvesting and wireless power transmissions. And it will also have wireless fusion with AI, machine learning in every plane and every layer of the stack, including the physical layer. So with respect to the cognitive integration and access of near or higher range communications across different geographical region, so that we can have vehicle to everything connectivity. We have ultra reliable low latency applications. We also have radio access networks using machine learning part, non-terrestrial and terrestrial communications. Also we can also have 5G new radio, Li-Fi technologies also comes into play. So I mean to say here, with this seamless connectivity, which is supposed to happen in the next few years, we can integrate different types of devices which are located across different geographical region, like in space, air, ground, or underwater. And then there will be a huge demand with respect to the connectivity and preservation of these devices for seamless data transmission among themselves. So there may be some sort of we can say challenges and use cases that must be there. So for example, if 6G network connectivity about to happen, then it will consisting of multiple connectivity and cell-less architecture that would be the prerequisite for connection among different entities, and it will provide the seamless mobility and integration of different kinds of links. That will also schedule different types of resource management and need for new network design policies. And it will the use cases for this particular part is pervasive connectivity, unmanned mobility, holographic telepresence, e-healthcare systems. We also needs to have 3D network architecture that will consisting of ubiquitous 3D coverage, seamless services, and it will also provide the topology optimization and energy efficiency with respect to the pervasive connectivity and unmanned aerial vehicles mobility. And if we talk about advanced access backbone integration, so it will provide the flexible deployment options, outdoor to indoor communications, scalability, scheduling, and interfaces would also be one of the issue. And use cases is again pervasive connectivity and e-healthcare. So those are some sort of I mean to say here enabling technologies which will part of the 6G connectivity among different entities. And then what are the potential of using of all those applications or standards, and what should be the challenges association for integration of all those in different network domain, and what are the use cases association for this network connectivity. So all in all, if you can see that the overall picture of connection among different entity will look like this. So it consisting of satellite communication, like geo satellite communication is there, and we have some repeaters, LEO satellite and quantum repeaters would be there, which will be consisting of space networks that will be for connection of different satellite to this aerial communication. These satellite communications comes into play with respect to this UAV airborne backbone systems, and these airborne backbone system are used to connect across different, we can say, UAVs, which can be used for integration of transmission between terrestrial communication and undersea communication. So this is a four-layer architecture, I mean to say here. At the underwater sea communications, we have these types of devices, marine or some other devices may also associated with this. So they are interconnected with their access point, which may be located across these terrestrial networks, and this satellite Earth rotations communication would also happen with respect to this quantum repeaters on this particular part itself. So we can say that this architecture will give you a clear picture that what does it mean by this the space communication, what does it mean by the aerial communication, what does it mean by the terrestrial, and what does it mean by the underwater communication. So all these four types of communications will provide the seamless connectivity among different devices, and these devices may be located across any location in any part of the world, and then these are interconnected with each others, provide seamless connectivity, and they will provide data transmission among themselves for better connectivity, resource management, and other part of the communication systems. And obviously at this point of time there may be some issues that needs to be taken care of, and one of those issues is that if we have to take care of the routing associations among these devices, so how to take care of the network management system, that will be one of the issue that needs to be taken care of at this layer itself. Hello. We should be aware of how the communication between different entities will happen in this particular scenario, and you can see that there may be some certain issues with respect to the at this particular layer. There are some other issues with respect to at this layer. There may be some other issues that are with respect to this. I mean to say, depending upon in which particular type of communication we are dealing with, there are different issues that should be taken care of, but there are some common issues which can be taken care of among all these entities. So one of the common issues is about routing management. That will be a prime issues among all these communication part, and second part is about network management. So you are aware of what does it mean by the network management system. So network management system is all about that how you will define certain routing protocols which will take care of the communication between this device and this device, or between this device and this device. So how you will take care of intra-domain or inter-domain routing mechanisms, and in between these the intra and inter-domain networks, not only this will be able to transmit the information to this nearest access points, and from this access point these will be a flying base stations. I mean to say these are flying base stations. So these are uh, flying base stations. So these base stations will be communication with the next base station, which is again a flying base stations. So again here the concept of intra-domain and inter-domain routing mechanism comes into play. So not only these flying base stations are with communicating with each other, they are also communicating with their counterpart in the this satellite communication itself. Similarly, from here itself, if some devices are located at underwater communication, so they will also be able to communicate to the access point which may be located across the terrestrial communication. So all in all, this will provide ubiquitous connectivity among all these devices which may be located across different geographical locations, and within these different geographical locations they will be able to communicate with each other. So so there are certain technologies which are being used in this upcoming 5G or 6G technologies. So one of those is nano networking. So this nano networking, this is nano IoT, is based upon molecular communications. This will provide graphene and metamaterials that can be used to build nanometers range devices. So because once we needs to provide the nano communication or molecular communication among different devices, so what should be the material that must be required for nano communication among different devices? And physical layer design for molecular communication is also one of the key challenges that needs to be taken care of. So among these, we should also taken care of bio networking, that is biological cells that are used for communication using IoT part, and there must be some novel routing mechanisms that must be developed between bio IoT and nano IoT or nano communications in comparison with traditional IoT infrastructure. So apart from this, we should also taken care of this optical networking or optical communication and 3D networking part, that is drone based user devices and drone based base stations that are enabled to communication, as we have already discussed in the previous slide as well. So the overall, I would say that if we have to implement this 6G network connectivity and networking, so this will be consisting of the efficient utilization of bandwidth spectrum, and this will consisting of density of deployment of base stations in kilobits per second. So this will be consisting of
रजिस्टर करके फिर देखो
अटल एकेडमी है पर्वती. This will consisting of the network management part, and this will also consisting of latency and reliability, and this will consisting of capacity. So you can see that if we talk about 60 use cases that will merge these applications like unmanned aerial vehicles, audio, AR, VR applications. So this will consisting of that how much per user data rate we can acquire, and what is the peak data rate that we can acquire, or what should be the air interference latency that must be required. Because ultimately what will happen that all of these applications like AR VR applications, like telepresence application, like e-healthcare application, or industry 4.0, or if we talk about unmanned aerial vehicles, so all those applications have different requirement with respect to their reliability, with respect to air interference latency and spectrum efficiency that is being used. So there are different parameters or different, we can say, values that must be required for fully automation and ubiquitous connectivity among all these devices or all those applications which we have mentioned at here for these upcoming 6G use cases, like for pervasive connectivity we require different types of we can say bandwidth, spectrum efficiency, per user data rate, how many number of devices that are supposed to be connected with each other with respect to the energy efficiency as well. So the capacity of any channels which is supposed to transmit the information between different devices which are part of these applications is obviously can be defined with respect to one of the core parameters nowadays, which is called as the bandwidth, and second one is the number of signal levels. So you see that if we have this information, let's say this information is there, right? So this must be converted in the form of some sort of signals. So these are some sort of signals that must be converted into this information. So once this information has been converted into these signals, so these signals are supposed to transmit on some channel. So this channel is, let's say this channel C is there. So every channel has some capacity. So let's say this capacity of this channel must be defined in terms of the bandwidth association with that particular channel. So that's why you can see that for efficient transmission of these signals which are associated for a particular application, we must have the bandwidth association for those applications like 5G or 6G and efficient spectrum utilization. Let's say for AR VR it is 100 Mbps, and we should also have the latency association with this. This is for 6G, this will be near about 100 microseconds association with that, and for other application these types of number of connections we require for pervasive connectivity among all these devices. So similarly the other attributes are also there. For example, in 5G we have 10 raised to power 6G connection per kilometer square, but here we have 10 raised to power 7 connections per kilometer square for upcoming technologies to be deployed among for all those types of applications which we have mentioned at here. So all in all you can see that we needs to have this ultra band low latency applications, which is a requirement for upcoming all 6G deployment across different geographical region. And for realization of all those applications, we needs to have full bandwidth spectrum utilization, and this full bandwidth spectrum utilization must be maintained with respect to different attributes like reliability, air interference, latency, spectrum efficiency, speed utilizations, etc. So these are some indicative, I mean to say here, these are some indicative attributes which must be maintained or which must be taken care of with respect to the efficient utilization of all these parts associated with that. So you can see if we have the 6G bandwidth spectrum, so there must be some sort of peak data rate that must be required with respect to in comparison with 5G and 6G. So in peak data rate in 5G we are talking about 20 GB per second, but here we are talking about 1 TB per second. So here we have experienced data rate is 0.1 Gbps. Here we have 1 Gbps per second. Peak spectral efficiency here 30 bits per second hertz, here 60 bits per second hertz. Here we have a maximum bandwidth of 1 gigahertz. Here we have 100 gigahertz, and area traffic capacity here 10 MB per second per meter square. Here 1 GB per square meter square. So these are number of devices which are connected 10 raised to power 6. Here we have 10 raised to power 7 devices. A latency of 1 millisecond. In here we have 100 microseconds, and reliability is also associated with jitter mobility association with that.
Excuse me, sir, you're muted.
Are you getting my voice or not? Hello?
So we're getting it now.
Okay, okay. Sorry, I think some network connection was there. So I mean to say here that with respect to 6G network connectivity, there are some research challenges are also there. So those research challenges obviously will increase the hardware connectivity, obviously. So as we have already discussed that so many number of devices are supposed to be interconnected. I mean to say at 10 to the power 7 number of devices are interconnected with each other. So that will create a hardware complexity among all those network infrastructure part, and also it will consisting of wireless energy harvesting is also one of the key concepts. So what should be the underlying technology that needs to be there for connection of these devices wireless, and then they will harvest the energy from the nearest base stations, and how it can be used for wireless energy harvesting. Then there must be some AI based adaptive transmitters, and there must be some dynamic radio resource allocation should also be there, and there should be a massive connectivity association with different types of net devices that are supposed to be part of this 6G revolutions. And security and privacy based distributed models would also be the need of the hour, and how does intelligent cell less architecture can be designed for communications among different devices. Similarly, how the integration of space, air, terrestrial, and maritime communications would happen, and management controls for AI-based application would also be one of the key issues that must be required. So, all in all, we can say the underlying network infrastructure which will take care of routing and resource management issues among different devices. So these issues with respect to bandwidth management, resource management, or we can say network policy management, access control mechanism, along with data analytics part will also comes into play. So how to cope up with this issue? So because uh, these all are consisting of distributed network infrastructure, and with respect to this distributed network infrastructure, all these devices are interconnected with each others, and it's not possible that all of them send their data simultaneously to the centralized server. Let's say this server is located at here, and all of these devices, if simultaneously are trying to send their data to the centralized server, then that may create a chaos for the end users also. So to cope up with these issues, because some of these devices, all of these devices, or some of these devices are intelligent devices. So these are intelligent devices in the sense that these are autonomous devices, where in the sense, so these intelligent devices are interconnected with each other, and they are independent with respect to taking decisions at their own. So once these devices are independent and intelligent to take their decision at their own, so they must be having some sort of algorithms that is based upon machine learning or deep learning, or in broad sense we can say these are AI based solutions. So these AI based or machine learning or deep learning based algorithms or models which has been deployed across these nodes, they must be having some high computation power. They must have some high computation power, and this high computation power would renders them or limit them for sending their valuable information to the centralized servers every times they needs to update their model. So the better solution for this types of scenario is, uh, we can say, the association is federated learning, and the importance associated with federated learning is that whenever you are trying to execute any model in any advanced data analytics part, so it is not all about the base technology, but it's all about how to access the data association with that. So this was the Harvard Business Review that has been revolutionized. So for execution of any models, whether that particular model is based upon Alexa, or whether you are using a smart gaming, or whether you are using online, autonomous vehicles, or whether we are using this smart ecosystems or smart energy harvesting system, or whether we are using some fraudulent devices. So data is the new oil for all those applications. Until and unless we didn't had any historical or current data or some other attribute associated with that, so we cannot make an efficient decision, we cannot create an efficient decision based system, because every efficient decision based system obviously based upon some records that may consisting of some numerical values, that may consisting of some audio, videos, and various other attribute association with that. So this is the prerequisite for that particular part. So in this context, the new paradigm that has been shifted nowadays is federated learning. So this federated learning is a paradigm shift which is from this centralized through this decentralized data. So what question here arises is that, is there any limitation from the existing centralized database system, which is a legacy system which has been used by the existing systems, and what is the new in this decentralized data paradigm which we people are talking about in the next few slides. So usually what happens is that traditional learning is, we have the location of the data is safely inside the servers, but data distribution is partitioned homogeneously. So but in the case of federated learning, which is a new concept, in which we have the data locations which may be distributed across millions of devices. So these devices, as we have talked in the previous slides, that in 6G connectivity are associated for the federated learning. So this 6G connectivity provides the ubiquitous connectivity among all these devices, and these devices are distributed across different geographical locations. So as these devices are distributed, or as these devices are connected or distributed across different domains, so these devices obviously have the data association with them. So this data is distributed rather than the, it is located inside particular server itself. So it is distributed across different geographical locations. So these locations may be obviously consisting of a 4-tier architecture, that may be on underwater, that may be on terrestrial communication, that may be on space, that may be consisting on sky. So all these four types of we can say communication paradigm or location consisting of different types of devices, and these devices are located across different regions, and these regions will be consisting of devices which may be consisting of data that may be distributed across millions of devices, and the distribution of this data is highly uneven because obviously the underwater communications has different types of data. Then we have terrestrial communication that may consisting of different amount of data, different types of data association with that, and then we have under UAVs or we can say flying robotics platform that may have another data, and space communication also have some other data. So this data is association with different parts, but in case of the traditional learning, latency was very low, but here in the case of federated learning, latency is high because obviously the general reason for that particular part is that data is distributed across different geographical regions, and from these different geographical region we have to taken care of data for computation parts. And throughput in this case, because data is local and latency is low, here we have throughput is high, here we have throughput is low. So but the key point of discussion is what is federated learning and why there is a requirement of this, why there is a requirement of federated learning, right? So, and how it has been used in today's day, and the very basic learning algorithm, that is FedEx, is there, and challenges that are faced in federated learning environment, and then we will include that particular part. So you see, as we have already discussed, the traditional setting in machine learning consider a centralized database server. So for example, it is a tightly integrated systems, but in the real world scenario, data is often decentralized across multiple parties. So for example, at here, if we have a traditional data center, so all of these devices are traditionally connected to this centralized servers, and from this centralized server we will be able to access the data association for different applications. I mean to say will be a tightly coupled system. So, but in the case of real world scenario, we need to have a loosely coupled system where we have the data associations from different applications, and these different applications are associated or distributed across different geographical regions. So that may create some sort of problems in our traditional database systems. Just wait for a minute. So I mean to say here that these are tightly coupled systems, so we need to have loosely coupled systems. So here you can see that federated learning consisting of this type of paradigm where each of these devices has their own uh, training model, and this training model can be passed and integrated using TensorFlow federated to a global part, and this model has not been transmitted to the server, but rather than the parameters are transmitted. So using those parameters, this model can be trained in these geographical locations, and then it can be transferred to the location as per the requirement of the end users. So there are a number of applications for this federated learning part also. That is one of those applications is voice recognition system, and this consisting of adaptation to pedestrian behavior on autonomous vehicles. We also have personalized healthcare. We have predictive maintenance for industry machines, etc. So there are a number of applications. So the traditional, I will say that traditional centralized servers consisting of sending the data may be too costly, because self-driving cars are expected to generate several TBs of data a day. So some wireless devices may have limited bandwidth power. So data may be too sensitive. So we see uh, a growing public awareness and regulation on data privacy. So keeping control of the data can give a advantage for the business and research in the years to come. So how does a machine learning based model will work it out? So for example, let's say generalized machine learning based model will look like this. So we have to classify between a positive sample and let's say between the negative samples, and using those positive and negative samples we need to design some boundaries which will segregate positive samples from the negative samples. So the local data in this case may be too small, so we may have subpar predictive performance due to the overfitting problem association. So in non-statistical we can say significant results, that may not be a good choice to deal with the local data. Rather than we should be taken care of global view of the data, that different applications which are using it from different locations, and this data is in distributed natures, and this will not obviously give you a true picture of what you are expected to have from the results. So what is the goal of overall goal of federated learning? So its aim is to collaboratively train a machine learning model while keeping the data decentralized part. So step you see here we have the initialization of this model, and then the replica of this model will be on these devices. So these are the devices which will keep track of uh, the local copy of this model which is being executed across different geographical regions. So each parties can share their local update for the aggregation. So this party also share their local aggregate value. So for example, here we have this updation for this particular model. So this will be shared with this server itself. Similarly, this party also share its local update for the aggregation at here. Similarly, this party also share its local aggregate. Similarly, this party also share with this local update for the aggregation. So you can see this server will take the view from all of these four models which are being trained across different geographical region in a distributed manner, and there is no need to transfer this whole model from this location to this location, because that will be a costly process in terms of bandwidth and other resources consumptions of the network which are being used. So rather than we can train it based upon the parameter passing which depending upon which what type of parameter has been passed from this model on this particular server itself. So this will be a local we can say a copy of the model which is being shared among these devices. Then parties update their copy of the model and then again iterate that particular solution. So our aim in this case is to have the final model to be as good as the centralized solutions, or at least better than what each party can learn on its own. So after the local aggregation value which has been passed from this node to this node, so this node again will pass the updated value to these nodes itself, and that will increase the efficiency of these learning models in this particular scenario, because after passing out the parameters to this centralized server again will pass the information uh, to these individual locations who will train its own model as per the requirement of this centralized nodes, right? So what are the advantages of this deep learning based federated learning model? It has lower efficiency. It has obviously ensure privacy. It will have the less power consumptions, and it can be used immediately in any network scenario. So there is a little bit difference between federated learning and this distributed learning. In case of this federated learning, data is distributed. So in distributed learning, data is centrally stored in data centers. So the main aim or main goal is just to train faster. So we control how the data is distributed across multiple workers. But in federated learning, data is distributed and generally local. Data is not independent, and it have identical distributed ID which is imbalance apart. So there are certain we can say issues which needs to be taken care of while designing a federated learning based solution. So those solutions consisting of we need to maintain the privacy constraints, we need to deal with the limited reliability or availability of the participants, we should have achievement with respect to robustness against malicious party which are being taken care of from different parts. So there may be some cross devices or cross silo part also there. Like for example, if we have large participation, let's say up to 10 is to power 10, so that in that case we will use the cross devices in federated learning. Otherwise we can use the cross silo if we have less than 100 participants. Here data size is small at every devices, but here data size is medium at each devices which have limited availability and reliability. Here we have reliable parties or almost always available. So some party may be malicious in cross devices, parties are typically honest in cross silo. So the server architectures for fully decentralized federated learning would be consisting of this part, whereas in fully decentralized we have this device to device communications and no global coordinations, only the local aggregation would be required, and naturally scales to a large number of devices can be possible in this part. Here we have server client communications, and global coordination and global aggregation is required. With respect to that, a server single is a single point of failure and it may becomes a bottleneck part. So what are the various research advancements that are occurring in federated learning part is association? Because in 2016 this FL was coined by Google researchers, and in 2020 more than 1,000 paper on federated learning in the first half of the year compared to just 180 in 2018. So we have already seen that there are some real world deployment of companies by the companies, and researchers are already there using this novel concept, and several open source libraries are under deployment like PyShift, TensorFlow, Federated, Fate, Flower, Substra. There are a number of federated learning concepts that are being developed. So it is highly, we can say, multidisciplinary, which includes machine learning, optimization, privacy and security issue, and network infrastructure associated with that. So this was the baseline algorithm for federated learning part. So here we have k number of devices are the clients, and each party associated have a data set of endpoints, and these data set be the joint database and total number of points that we want to resolve. So we have to find out the minimum of this RP with respect to the input attributes as theta and d. So using this we need to aggregate or solve these particular equations with respect to the parameters, that is theta or model parameters, which consisting of logistic regressions or neural networks. So all of you are aware of, I think, aware of how a neural network has been trained. So neural network has been trained using backpropagation algorithms, which will be consisting of finding out the difference between the observed value and expected value, and this observed and expected value we define some error functions. So once that error functions can be needs to be minimized, so once we error function has been minimized, then we say that this neural networks has been trained with respect to the input features corresponding to finding out an optimal solution. So this is the algorithm association for Fed average on local segregate data, and this is the result obtained for this federated learning concept. So you can see that with the inception of different learning rate, we will have the testing accuracy that is more than 80% has been observed in each different communication rounds. So you can see that convergence to the optimal model can be granted for federated learning with passage of times, but it will also include some known trivial issues also. So I think this part is association for uh, consisting of different types of CNN layers on max pool layers on MNIST datasets. So this consisting of different types of sample digits for identification of different types of uh, digit categories. So platform use has been this. So we will have these types of impact of resource heterogeneity on training data set. So you can see if we have 4 CPUs, 2 CPUs, 1 CPUs, and the other parts association with that, the training time has been increased substantially. So along with this, you can see the distribution of data parties and CPUs are there. So if we will have the number of clients 4, which has been consisting of number of CPUs, and CPUs per clients are like this. So you can see this is will consist of fully distributed solutions where a CPU per clients has been varying with respect to the number of CPUs and number of clients, and based upon this simple requirements, the pre-round training time and source management across different data sets has been revolutionized or has been identified. So the data heterogeneity points on training dataset is also one of the core issue, or we can say core issue, or core we can say concept that needs to be memorized, because here you can see if we going on increasing the number of data points, so from 100 to 200 to let's say 5000, so the how much is the training time and how this training time has been increased substantially. So we have 14 clients with different data set size, so that data set size vary from 100 to 5000 data units, but with the same amount of CPU resources. So the training time gets linearly increased as the data size gets bigger. So data heterogeneity can significantly impact the basically the federated learning system training time. So how to deal with non-IED data? So when local database are non-IED, so it will Fed average suffers from client drift. So you can see at here. So here we have different access points like X1, X2, X3 up to Xn parts are there. So here we have the true optimality part is like here, and here we have client optimality part should be at here. So to avoid this drift, one must use local updates or smaller learning rate which hurts the convergence part. So this was taken by the this well-known conference on federated learning, that is in ICML, that has been published. So learning from non-IED data is difficult or slow because each party wants to model to go to a particular direction. So this was the observation that has been done in this particular part. And the next part is how to make the privacy preservations. So privacy preservation is done with respect to the client update and server update, that will be consisting of true drift from the normal value. So this true drift is a significant part that how much we can have the true optimal value and client optimal value, and how much drift has been observed from the optimal value with respect to the training of this model in a federated learning environment. So there are certain open problems that we people can take care of whenever we have to design a network-based solutions or network science using using federated learning concept. So first of all, we need to take care of detection of data poisoning attack, and while maintaining a secure aggregation that is being used for making out aggregation between different data points, and there must be asynchronous model updates in federated learning and its coexistence with secure aggregation. So it will also reduce the communication overhead, and the uses of differential privacy can also be used for making out the privacy preservation in network science based applications that we have discussed for 6G scenario in federated learning concept. So that was the and from my side, I try to cover all those concepts which will consist of the basic part of the network science, along with how we can use the network science paradigm in upcoming 5G or 6G technology, and with respect to 5G and 6G technology, how we can cope up uh, uh, with this network science paradigm. So you can see that network science is a broad concept, and this broad and interdisciplinary concept consisting of revolution of industry 4.0 or industry 5.0 revolutions, and the core of any industry 4.0 or 5.0 solution is based upon data revolutions. So data revolutions, how to deal with this data revolution is one of the core issues nowadays in front of the research community, that how to deal with machine learning based algorithm which will take care of obviously the prediction part, which will be consisting of aggregation, security and privacy, network management, resource management part. So those are the some of the we can say highly integrated issues which needs to be taken care of while designing any network based solutions for these types of applications. So I hope you have find this lecture very informative. If you have any questions, so you can ask your queries. Thank you very much.
Thank you so much. We will be ending the session now, just after the thank you speech from our speaker, our member.
Thank you, sir. That was very enlightening and enriching session. This will help our listeners to understand the topic in a very organized way. Before moving forward, I would like to inform everyone that feedback forms are available and we would be delighted to get your feedback. To sum up the present session, we look back to the short summary of it. We learn about the evolution of networking and communications in space, aerial, terrestrial, and also the 6G technology. Evolution of 5G and its integration to a strong technology to meet the novel network demands. 6G networking and connectivity with UAV technology in space, aerial, terrestrial, and undersea. We also came up with the research challenges for 6G technology like increasing hardware complexity, low power circuits with high performance processing capabilities, dynamic ratio, resource allocation, AI based management and control, etc. I would like to express my gratitude to all esteemed delegates of the webinar for their presence and contribution to make this webinar a great success. A special thanks to the organizing committee and teaching staff for their unteaching support and coordination. A heartfelt thanks to everyone for their active participation. With these warm words and a kind message, we came to an end of the session, and I would like to inform everyone that we have a break now and all participants are requested to join us back at 11:30 a.m. Thank you.
Thank you so much, Jisha. Next session will be starting at 11:30. Kindly be here at time. Thank you. And feedback links have been provided.